Today's daily Go problem of the day is reschedule meetings for maximum free time part 1, number 3439. For this problem, we're given an integer called event time, which denotes the duration of an event, where the event can occur from time t is equal to 0 to time t is equal to the event time. We're also given two integer arrays called start time and end time, each with a length of n. These represent the start and end time of n non-overlapping meetings. So there's an n amount of meetings, where the ith meeting occurs during the start time of I and end time of I. So that's the duration of that meeting. We can reschedule at most a k amount of meetings by moving their start time while maintaining the same duration to maximize the longest continuous period of free time during the event. So we want to move our meetings. It's going to maintain its duration, but we can only move the start time. So we don't want to overlap or put the first meeting ahead of the second meeting. Then the relative order of the meeting should stay the same, non-overlapping, and then we want to return the maximum amount of free time possible by rearranging the meetings. So for this example, we can move the start of this meeting to 0, and then we have from 1 to 2, 2 to 3 as free time, or we can move this meeting all the way to the right, which would leave from 0 to 1, 1 to 2 as free time, which is what they have done. Here's another example. We can move, we can move one meeting, and if we move this meeting over to the left by 1 unit, we get this 5 plus this 1, so it's 6. So from 3 to 9, we get free time. So let's go ahead and jump into this problem. We're going to use a sliding window technique, and the sliding window is going to contain k plus 1 events. That's because we can move k, and the plus 1 of k is going to stay still. For example, in this example, we can move one meeting. So we're going to keep this meeting in check, and we'll add this meeting to our window. Well, we know that we can move this meeting all the way to the right or to the left, and that will create a gap, right? So from 3 till 9, because we move it over by 1. So we're going to have a k plus 1 sliding window. So let's go ahead and jump into this. First thing is we're going to initiate a variable n. So int n is going to be equal to, like they define it, it's the start time dot length. So that's simply just how many events we have. And then we're going to have our integer result, which will start at 0. And then our integer t will be the time of each event, which will be equal to 0. So the reason we're going to have a t variable is we're going to keep track of the length of the events in our window, and then we will subtract that from the total time of our window, and that will give us the free time gap. So we don't have to actually manually move all these objects, right? If we look from 0 to 5, that is a 5 length interval or window, and we know that there is 3 units or 3 hours worth of meetings. We can subtract the 3 from the 5 and know that no matter how we organize it, there's 2 hours worth of free time that we can put together in a k plus 1 sized window. So let's go ahead and jump into that. So our main loop is going to be a sliding window of size k. So for each integer I is equal to 0, as long as I is less than n, I can increment. So we're going to slide over the start time and end time arrays with a window size of k, while I is the end of the current kth window. Now we're going to add our current event's duration to our total meeting time. So t is going to plus equal the end time of I minus the start time of I. So again, this is representing the time of that event that we're currently looking at. And then next, we're going to compute our left and right bounds of this gap window. So is there free time to the left or right of this window? So we're going to have an integer left bound is going to be equal to if I is less than or equal to k minus 1, then it's going to be equal to 0. Otherwise, it will be equal to the end time of I minus k. So if I is less than k, this is the first few events. So we haven't seen k full ones yet. We have not seen a k amount of events yet. Our left value can be 0, the beginning of the event. Otherwise, left is the end time of the event just before k events, so we're keeping it there. We're going to compute what the time available before these k events starts. Then we can move on to our right point. So int right is going to be equal to, if I is equal to n minus 1, it's going to be equal to event time. Otherwise, it's going to be equal to start time of I plus 1. So similar concept. If we're the last event, so there's no next event, the right will just be the end of our event time. Otherwise, our right will be the start of the event just after the kth window. So right before we start a new event, which would require us to move k plus 1 events. Now we're going to compute the total gap. So that's going to be our result variable. It's going to be equal to the math.maximum value of either our current result that we've previously computed, or the right minus the left minus t. So we're going to compute the right minus the left, which is the total time in the region. So if our region's from 0 to 5, we have a 5-length region. And then t is going to be the total busy time from the k events. So we know that there's 3 hours of busy time. We're going to subtract that from our total time. So 5 minus 3 is going to be equal to 2. That's going to get us our value for the, it's going to get us the value for that window, that max value for that window. And if it's greater than our previous max, we'll update that as well. Next, we're going to slide the window forward. So if our I value is greater than or equal to k minus 1, so once the window size hits k, we're going to start removing the oldest meetings. So I needs to be greater than or equal to k minus 1. Then our t will minus equal the end time of I minus k plus 1. So whatever the least most event is, we can remove that. So same thing with our start time of I minus k plus 1. So we're going to get rid of the very backmost event that would no longer be part of our window. And then we can simply return our result. So if we run this, passes our test cases, and if we submit it, passes all solutions. So thank you, and follow for more daily LeetCode solutions.